Hello and welcome back to Unreal Engine 5, Blueprint Mastery, Door Systems and Interactive Portals. Previously we finished with our lever door basically. I think we called it lever in the end. Yeah, lever door. It didn't update here because it doesn't auto-update the names. So we can update it. Also, one thing that I noticed is that in the update widget text, it shouldn't say seems unlocked. I'm gonna delete this. I'm just gonna say locked. And that would be it. So now we finished with the lever door. What we did was we added a few texts also, and we finished with the animation part of the lever. And we added some error messages also, just in case the door actor is not set. Now, let's continue to the next part. Let's make our level 6, I think, 7. Our level 7 visible. And this is the turning point afterwards. We're going down way. Let's begin with updating our blueprint interface for doors. We're gonna add a new function called solved. And in this function, we're gonna use an output. And we're gonna name it solved. This we will use to our lever. So we're gonna go to our lever and go to class settings and add an interface, which is BI doors. Now, we're gonna go to interfaces. We're gonna compile actually first. Interface name collision in blueprint because of the boolean solved. So let's call this boolean is solved. Yeah, you can't have the same name variable twice, and if it's belonging to the interface, it also belongs to the blueprint, and this creates a problem. I have to compile this first, and now this one, and it's done. Let's double click on solved and bring the is solved and connect it here. So now, whenever solved is called, we're gonna return our is solved variable. Where do we call this is solved? Let's go to our new door. So we're gonna duplicate the lever door. I'm gonna call this multi-puzzle door. And we're gonna open it. Not a lot of things will change here. The only thing we will change is that we will create a new function. Let's call this check puzzle answers. And it will also have a boolean output. All puzzles solved. Okay, we will fill it next. Now what we're gonna do is use this event unlock door, which because we copied, it became a normal event. Let's go to the interface, and let's call the interface one. This happened because we duplicated the blueprint. So we're gonna go to our event unlock door, and we're gonna bring the check puzzle answers. And if this returns true, we will unlock the door. If not, we will rattle. So door rattle over here, and instead of calling this from the switches, we will be calling it when we press E and the door is locked. So when it's true, we will, what was that called? Unlock door event. Now, when I call it inside the blueprint, see that it doesn't have this envelope over here, but it has the target at different color. This happens when you are internally calling a blueprint interface function. So now, to continue with our function check puzzle answers. First of all, we need to create a reference to the puzzles, as we did for the switch back here. we need to do for the door and the puzzles. So how do we do this? We're gonna create a new variable of type actor, object reference, and we're gonna name it puzzles. Now, why puzzles? Up to now, we've been using single variables, which means they have a single type container. And why I say this word container? Because we have three more different types of containers. If we select the variable puzzles and go over here, we can see this, make this variable container array, set, or map, which is the other three different type of containers. So one container is the single one, the second one is array, third one is set and map with specific rules on each one. But their basic functionality remains the same, keeping a list of elements, a list of variables, basically. We're going to be using array, which holds one type of variable, map can hold two types of variable, and set is every variable basically in the list has to be uniquely. Now, we will select the first type of list, the array one, and one more important thing about these lists is to think that every variable they hold in the list has a specific order. For example, if I compile this, we can see puzzles and array elements. And if I click one array element, I have one array element here. Second one, third one, and these ones are in a specific order. This is 0, this is 1, this is 2. The same follows for the rest of the list also, that they keep a specific order and always keep this order unless we change it. Now, when I said that the set actors need to have a unique element, it means that the first element has to be not the same as the second one. For example, if this was integers, it would have been 1, 2, 3, it couldn't have been 1, 1, 1. Let's demonstrate this for a second. Let's change the variable type to integer and let's compile. See, it resetted the elements. So I added 0. If I try to add again, I cannot because 0 already exists. If I turn this to 1, then I can add. If I try to turn 0 to 1, it won't let me. If I try to turn 1 to 0, it won't let me. So I have to turn this to 2, for example, and then it added 0 again. So on goes on. It's very counterproductive to fill sets manually. Anyway, let's go back to our array, which can hold multiple times 1, for example. I have to compile to do this. Multiple times 0, for example. And it should be of type actor without type. Okay, so an array of actors. So we have this little nifty list of actors which is not populated. We will make it instance editable and we will expose and spawn also, and we need to compile and then go on our map and let's bring our new actors. Let's bring two levers, one over here and one over here, and let's bring the new door also, multi-puzzle door. I will place them better later. Just want to fill the puzzle array. So I'm going to press this button over here, one more, and I'm going to select the first one to be this one and the second one to be this one. Now if order mattered, it would matter the way we select them, but in our case we will just be checking if both of them are solved. Now, we didn't need to actually fill the actors right now because the code would be, let's go make the code actually. Let's go to check puzzle answers, and now we will bring our new puzzles array. Now we will discover a new node, which would be the for each loop. Now, besides the for each loop, there is also a for loop and a for loop with break and a for each loop with break. And of course, there is a reverse for each loop. Now, what is a loop? Because the most common word, as we can see here, is a loop. A loop lets you repeat actions multiple times as fast as it can run. As we can see, it has an execution in, a body loop, and a completed node as the execution nodes. And all here are the same with the exception of break. Break is that we can call somehow to stop whatever this is doing. For example, in things that we are searching for something and we find it, we can stop when we found it and complete the loop. And the other difference is that these two, for each loop with break, we have an array input, whereas these ones we set manually to do something a specific amount of times. For example, if we wanted to happen twice, it could be a loop from 0 to 1, because loops and arrays, that's also something important, and the other containers, begin with 0 as the first index, the first number of the elements. We will have element 0, and then we will have element 1 and element 2. So this is also important. Now, let's delete this and let's make our for loop work. So what we're going to do is, and here comes the message is solved. We're going to ask is solved. No, we called it solved. Yeah, solved message. Now, this returns us if it's solved or not, the puzzle that we're asking. And also, just a reminder why we used an interface call, because this one is of type actor. So it means it can become again everything. It can become one switch and one lever and one switch. It can become one button and one switch. It can become a door and a switch, or anything. It can become anything. Whereas if we had the class type instead of actor over here, we had like BP, lever, BP lever. If we had this one, this array would only contain lever doors and we would be able to get information directly for them. But this makes it able to get any actor that implements this type of blueprint interface. Now, let's complete the logic of this. We're going to put a branch here, because if we just connected the return node over here, we would constantly, for every body, return if it's solved or not. But this function is about to check all puzzles, not only one. So the return node should happen in the end. Now, what we will do is that the first time we find a puzzle that is not solved, we're going to promote this to a variable, but a local variable this time. So it only exists in this function. And we're going to disconnect it actually. If one of them is false, we're gonna break the for loop. Yeah, use the for loop, each for loop, we need it with break, for each with break. Okay, with control, I'm just reconnecting all the pins. Okay, so when we find one puzzle that is not solved, we will turn this off and we will break the for loop. So what we also need to do is give it a default value of true. So if this never breaks, then this will return this new variable. Actually, let's give it a name also. Let's name it all solved. And this will complete it. Now let's explain it a little bit fast again from the beginning what we are doing. We are going through our puzzles. We have set a default variable, local variable. This means that this, whenever it runs, it begins as solved. Even if we turn it off, the next time this will run, it will begin as true because it's a local variable. Now, we're going through our puzzles with a for loop. We check if they are solved. If they are not solved, we turn this variable off and we are breaking the loop. And we are outputting the result. So, let's go test this door. Let's set the switches. Place them in the wall. Well, not in the wall, but is this? Yeah, it was just inside. No, it's opposite also. So we rotate it. And the door is also opposite. Yeah, I think it's fine. Maybe a little bit this way. Okay, I'm gonna get the player start. I'm gonna move it here. I'll press play. I'm gonna use the one switch. Oh, let's rattle the door first. It's rattling. Second switch. And it unlocked. Great. So we're done with this door also. Supposedly we can close it. Oh, maybe this door shouldn't open this way. Maybe, and just go to event graph. Oh, it opens opposite from the player. Okay. You know what? We're gonna leave it as is. If you want, you can play with the angle. Actually, we can just disconnect this and go towards 90, I think. Yeah, I'm not gonna leave it as is. I can't. I'm sorry. I can't leave it as is. Doing this. Yes, it works correctly. Because putting the angle always 90 disables basically the calculate direction. Anyway, we are done and we reached the time that we will make the physics items. Cool. I'm gonna see you on the next one.